Good day, grade 11s. Today we are going to look at the quadratic form, which is written in expanded form. And this is the one that we are used to when we talk of anything that is quadratic, the general formula that we have been working with, whether it is in number patterns or in equations. The one that we were seeing was something that looks like this. Now, if you look here, this is actually the expanded form of the one that we introduced yesterday, the one that says y equals to a x plus p squared plus q. And then remember, the p is your axis of symmetry at negative p, and then the q is going to mark the turning point. Okay, so now this version, if you are given the equation like this, remember this can say f of x, it can say g of x, or it can say g mapped onto. If you are given in expanded form, the first thing that would be easy for us is to find the y-intercept. If you remember the y-intercept, you must let x be equals to 0. So if you substitute 0 in here, this is going to become 0. If you substitute 0 there, this will become 0. So as you can see, the y-intercept is going to be c. So you don't have, if you are given it in the equation in expanded form, there's no need for you to even go through these steps. You can just get the y-intercept from the constant, the number that doesn't have the x on your equation. So if it is an expanded form, the last value all the time gives you or the constant term all the time gives you the y-intercept. Okay, so that's what I've written here. If the function is given in expanded form, the constant c is the y-intercept at 0, c. Remember, we have to give it as a coordinate. Now to get the x-intercept, we do the same procedure. We still let y be equals to 0, and so for x. And then to get the turning point, now as you can see, we were able to get the turning point here without any calculations. Turning point here was negative p q. So now to get the turning point, if the equation is written like this, means that you have to complete the square so that the equation can sit in this manner, and then you can be able to get your turning point. Now, how do we complete the square? Remember, we have to first factor out the a. So when you factor out a, this will be b divided by a, and then c divided by a. Then to complete the square, you divide this one by 2 to get that extra number that you must add to complete the square. So so you divide this by 2 and you square it. So if you divide by 2, it will give you b over 2a, and then you subtract it. And then because remember, this is an extra number that we have added, so we have to remove it to maintain the equation exactly as it was, and then you factorize. So you'll remember this when we do the examples. Okay, so you factorize this, and then it will give you the equation in the bracket form. I'll call this one the bracket form so that it's easy for you to remember that we've got two forms, the expanded form and the bracket form. All right, so now let's look at one example. We've got x squared minus 2x minus 8. As you can see, this one is an expanded form, and if we are looking for the turning point, we'd first have to complete the square. So let's do that. If you complete the square here, you get first have to divide this one by 2. So it's negative 2 divided by 2, which gives us this one gives us negative 1. So it's negative 1. Then you are going to square that negative 1. So when you square negative 1, it gives you this 1. Okay, now that 1 is the one that you are going to then subtract, because remember, it's a new addition, so it's an extra number that you put for yourself, so we have to take it away to balance the equation. Okay, so it's minus 1 minus 8, that was already there. Then you factorize this one, so it's a perfect square, so it will give you x minus 1, and this minus 1 is that one that you obtained when you were dividing by the 2. So I still insist that you write that so that you can be able, so it will be easy for you to get this. You don't have to spend time again trying to factorize this. Okay, now as you can see, now it sits as a what? As in bracket form, and then it's easy for you to get the turning point. Turning point is the negative of this number. So negative of -1 is 1, and then -9. So the turning point is over there, and then the y-intercept is going to be at 0, -8. And then to find the x-intercept, y must be equals to 0. So now to find the x-intercept, you can use any of these equations. You can use this one or you can use this one. But I advise that you use the given one in case you have made a mistake on this one. So it's better that you use the given one. All right, so that's what I did. And then now we are just trying to solve a quadratic equation. So a quadratic equation is you equate it, it's equal to 0 already, and then you factorize here. So when you factorize x minus 4 and x plus 2, and then x comes out as 4 and x comes out as -2, and then you can sketch as we did before. Remember, when you sketch, you must indicate the x-intercept, and then you must also indicate the turning point, which is 1, -9, as well as the y-intercept. So the y-intercept is over here at -8. Okay, so that is your y-intercept. Okay, so second equation, and the graph is upright like that, or it's a smile, because a here is positive. Okay, second equation, again, a is positive, and then it can also be negative. It can be a fraction. Remember, you just have to factorize that so that you ensure that this is positive. The x squared is always positive. So anything else you factorize, not divide, you factor it out so that it sits out here. Please go back if you have forgotten how to complete the square to our first chapter. Right, so so that's what I did, and then I completed the square. -4 divided by 2 gives you -2. Then you square that -2, it gives you 4. Then you take that 4 away, plus 3, and then it gives you that when you complete the square. So a turning point is going to be the negative of that, which is 2, -1, and then the y-intercept is going to be 0, 3. As you can see, the last number there, or the constant term, is 3, so it's going to be 0, 3. And then to find the x-intercept, factorize here. Vectors of 3 that add up to -4 is -3 and -1, which then gives you this. Okay, so turning point, x-intercept, y-intercept, and then the axis of symmetry. All right, now you'll see that I've written here. Okay, please do this exercise 4 on page 104 as prescribed. Now there's another method that is used to find the turning point that is described in the book, where to find the x value of the turning point, it will be -b over 2a. So your b here is -2, so it would have been -2 over 2 times 1. So that gives you the x value. So if you check the -2 divided by 2 times 1 is 1, which is what we have. Then to find the y value, you then substitute the x that you have found into the equation. So we found 1, so it will be 1 squared minus 2 times 1. So 1 minus 2 is -1. -1 minus 8 is going to be -9. Then you get your turning point. So you can also use this method if you find it easy. I like the one for the turning point, for completing the square, because this the concept of completing the square is very useful when you get to grade 12. So I prefer that you complete the square, but if this is what you understand, then you can use that method. It's also acceptable. All right, thank you.